Friends, welcome back to my channel. In our previous video, we have studied about one allotropic form of the phosphorus, and that is white phosphorus. Today, we will study about the next two allotropic form of the phosphorus, that is red and black phosphorus. If you have not seen the first part of this allotropic form of phosphorus, I'll provide you the link in the description box. Please go through that part first and then study this one. So without any delay, let's begin. Today, first we'll study about the red phosphorus, that is the second allotropic form of phosphorus. Now, first of all, if we talk about the preparation of red phosphorus, the red phosphorus is prepared from the white phosphorus by heating the white phosphorus in an inert atmosphere at 573 Kelvin. It means P4 on heating at 573 Kelvin in an inert atmosphere, we get P4. Now here, this P4 is white phosphorus and this P4 is red phosphorus. Though the formula is same in both the case, but the physical properties are quite different of white phosphorus and red phosphorus. So when P4 on heating at 573 Kelvin in an inert atmosphere, then we get red phosphorus. Next, if I talk about the structure, of red phosphorus, the structure of red phosphorus is like this. Now, this is connected with the second molecule. And this molecule is connected with the third molecule and so on. So it is basically a polymeric form of the white phosphorus. So red phosphorus is basically the polymeric form of the white phosphorus. Now next, if I talk about the properties, in property, the very first property of the red phosphorus is it is hard, crystalline, odorless solid. Just opposite to that of the white phosphorus. It is hard, it is crystalline, and it is odorless solid. Next, if I talk about, it has relatively high boiling and melting point. And we are comparing the boiling and melting point of red phosphorus with white phosphorus. So with white phosphorus, it has relatively high boiling point and melting point. Next, it is insoluble in water as well as CS2, means it is neither soluble in water and not soluble in the organic solvent, whereas white phosphorus is insoluble in the water but soluble in the organic solvent. So we are getting the different physical property, and the allotropes are the structure having different physical properties. So hard, crystalline, odorless solid, has relatively high boiling point and melting point. It is insoluble in water as well as the CS2. It is non-poisonous in nature. And next, if I talk about the reaction with O2 and the ignition temperature. First of all, let's talk about the ignition temperature. Its ignition temperature is 543 Kelvin. Therefore, it is not as much as reactive as compared to the white phosphorus, because we know that the ignition temperature of white phosphorus is 303 Kelvin, and because of this we always get white phosphorus under the water, but its ignition temperature is 543 Kelvin. Therefore, it is not so much reactive as compared to the white phosphorus. Next property, if I talk about, that is, it reacts with air. When it burns with air, it burns with air at 565 Kelvin. At normal room temperature, it do not burn with air. It burns with air. Burns with air at 565 Kelvin. P4 plus O2 at 565 Kelvin, it forms P4O10. Though it also produces P4O10, but if it is white phosphorus, then it reacts with O2 at the room temperature, and if it is red phosphorus, it reacts with O2 at 565 Kelvin. Similarly, it reacts with halogen, it reacts with sulfur, and it reacts with metals, but on providing heat. Means at room temperature, it means the red phosphorus doesn't react with halogen, doesn't react with sulfur, and doesn't react with metal. So if I have to write the reaction between P4 and Cl2, I'll write here triangle. Means on heating, it gives PCl3. P4 plus S8, on heating, it gives P4S3. P4 plus Na, on heating, gives Na3P. Though the products are same in all the reaction, but what is the difference? Because of the very high ignition temperature, because of very high ignition temperature as compared to the white phosphorus, it reacts with the oxygen, sulfur, chlorine, and the metals upon heating. Means not at room temperature, on heating it reacts with these substances, these elements, to form the product. Now next, if I talk about when we heat red phosphorus, it sublimes to form vapors. Means it undergoes sublimation on heating. It directly converts from solid to liquid. So it sublimes on heating. It sublimes on heating to form vapors. And when these vapors condensed, then we get white phosphorus. Means this red phosphorus on heating undergoes sublimation to form vapors, and then when these vapors are condensed, then we get not the molecule of red phosphorus, but we get the molecule of white phosphorus. So this is the method. This is the method of reconversion of red phosphorus into white phosphorus. Because red phosphorus is prepared from white phosphorus. Now when we condense the vapors, we again get the white phosphorus. So this is the method of the reconversion of the red phosphorus into white phosphorus. Now this red phosphorus doesn't react with any OH solution. And this property means white phosphorus reacts with NaOH solution, but red phosphorus doesn't react with NaOH solution. So this property is used in distinguish between red and white phosphorus. Distinguish between red and white phosphorus. Red and white phosphorus. And because of the polymeric structure, it is less reactive, as compared to the white phosphorus. So these are the properties of the red phosphorus, which can be easily understood by knowing the properties of the white phosphorus. Now we'll study the properties of black phosphorus. Black phosphorus. Now the black phosphorus exists in two forms. The black phosphorus exists in two forms: alpha black phosphorus and beta black phosphorus. First is alpha black phosphorus and second one is beta black phosphorus. Now, if I talk about the preparation of alpha black phosphorus is prepared from red phosphorus. Alpha black phosphorus is prepared from red phosphorus. By heating red phosphorus at 803 Kelvin, we'll get alpha black phosphorus. So by heating red phosphorus at 803 Kelvin, we'll get alpha black phosphorus. But when we heat white phosphorus at 473 Kelvin in an inert atmosphere, then we get beta black phosphorus. So alpha black phosphorus is prepared by heating red phosphorus at 803 Kelvin, and beta black phosphorus is obtained by heating white phosphorus at 473 Kelvin in an inert atmosphere. Now, if I talk about the properties, this one, that is the alpha black phosphorus is opaque. Alpha black phosphorus is opaque monoclinic structure, means the structure is monoclinic shape. But if I talk about the beta black phosphorus is orthorhombic crystal having layered structure. So if I talk about alpha black phosphorus, it has opaque monoclinic structure, and if I talk about beta black phosphorus, it has orthorhombic crystal having a layered structure. The bond angle of the beta black phosphorus is 99 degree. Bond angle is 99 degree. And if I talk about the because it is a layered structure, so the distance between the two layers is 368 picometer. 368 picometer is the distance between two layers. So we have a detailed structure study of beta black phosphorus, that is an orthorhombic crystal having layered structure in which the bond angle is 99 degree and the two layers are separated by 368 picometer. But in this we have only this detail, that it is the opaque and monoclinic crystal. Now if I talk about alpha black phosphorus, it doesn't conduct electricity. But beta black phosphorus can conduct electricity. Beta black phosphorus can conduct electricity. And if I talk about the stability of these two black phosphorus, both of them are highly stable. So these are the properties of the black phosphorus. So black phosphorus exists in two forms, that is alpha black and beta black. Alpha black is prepared from red phosphorus by heating at 803 Kelvin, whereas beta black phosphorus is obtained by heating white phosphorus at 473 Kelvin in an inert atmosphere. It is opaque and monoclinic structure. It is orthorhombic crystal having layered structure in which the bond angle is 99 degree and the layer are separated by 368 picometer. It doesn't conduct electricity, whereas beta black phosphorus conduct electricity, and both of them are highly stable. So this is all about the black phosphorus. So in this video we have learned about the alpha black phosphorus and beta black phosphorus and the red phosphorus. So all the allotropic form of the phosphorus are done. If you have any query related to any form of the phosphorus, then you will comment, you will give your question in the comment section. So students, that's all for today. I'll see you in my next video with a new topic.